First of all, I want to thank for the invitation from EduCare Taiwan, and also thanks Ms. Chen. And we actually we have a couple of times of communication before this webinar, and she's very kind and sharing very so much information with me. Yeah, sharing is about what my lab is working on recently. So the topic is the novel nanomaterial and their biomedical sensing and applications. And actually, in my department, there are also many other faculties who are working on different areas, such as organic chemistry, inorganic, biosensing, and medicinal chemistry. So today's presentation is not only limited to me, but if you are interested in some other areas, please do not hesitate to inquire us. Yeah, all right. We are more than happy to help you to study in Taiwan. Okay, right. So that's my name, and this is me, and this is my son. Although the picture, it seems he seems very just an infant, but he is actually 8 years now, 8 years old now. Okay, right. So my presentation. I will divide it into 3 parts. About the first is the introduction about what is nanomaterial and the Raman spectroscopy. And because Raman spectroscopy is a very important instrument in my lab. And meanwhile, I will also introduce what is surface enhanced Raman scattering. As India just mentioned, I think I will give a very brief introduction. And after that, I will tell you what kind of application of the as prepared nanomaterial in biomedical sensing, especially in biomedical, because as you know, in the past few years, the biomedical application or the jobs about biomedical are very popular, and there are also many openings about the biomedical related jobs. So I will tell you what my lab is working on the related area, and last it will be the conclusion. Okay, and I make a list here what kind of biomedical application in my lab, including the detection of nuclear bases, detection of NO. This is not no. This means nitric oxide. Okay, and immunoassay, pathogen sensors, and so on. I will tell you about this later. Okay? And first part is the introduction. And recently, my lab is working on the preparation of nanomaterials, especially plasmonic nanomaterials and quantum dots. So I'm telling you what is plasmonic nanomaterial. Plasmonic material means the nanomaterial which has the surface plasma resonance effect. So the surface plasma resonance means the electric field resonance effect happened on the or near the surface of nanomaterials, just like the schematic diagram here. The gray sphere is the nanoparticle, and the light green sphere is the electron cloud, free electron cloud around the surface. And actually the electrical field will oscillate with a certain frequency. And if the incident radiation has the same frequency with the oscillation, and the resonance will happen, which means we will see the light extinction effect. Yeah, this is one of the effect we can observe from the surface plasma resonance or plasmonic material. And meanwhile, this kind of nano plasmonic material, because the surface has a very intense electrical field, so it will have many fascinating application. And one of the application will be the surface enhanced Raman scattering, which I will show you later. And now I will introduce you about the other nanomaterial we are working on is the quantum dots. Quantum dots, in the beginning of the invention of quantum dots, they are all inorganic quantum dots like CDSE or CDS. But recently, we kind of prefer organic quantum dots or green quantum dots because the inorganic quantum dots are poison. Yeah, but with green quantum dots, it shows less toxicity and more biocompatible with the tissue or organs, something like that. Yeah. So recently we are working on the application and preparation of carbon quantum dots, and there's a brief introduction here. When the carbon material, yeah, because so far there are many different kinds of carbon material, including diamond. That is what I most like, and the graphite and graphene and carbon nanotube and so on. And the carbon quantum dots, like what I just said, is also one of the carbon material, and which is discovered in 2004. And usually we say the carbon quantum dot is the carbon material and the size is below 10 nanometer, but actually usually we will define carbon quantum dot is the size around 5 nanometer. And because the size is reduced to less than 10 nanometers, so it shows many different characteristics comparing to the bulk carbon material. For example, the fluorescence, the carbon quantum dots show fluorescence, which is not observed in nano carbon materials. Okay, so recently we also try to prepare carbon quantum dots with different precursor and applied in different sensing application. And other than carbon quantum dots, we are also working on the preparation of iron oxide quantum dots. And iron oxide is discovered just 2 years ago. 2 years, so it's a very new series of carbon dots, and we also use it in the sensing application. Yeah, I will show you later. Yeah, so these two kinds of different material, including plasmonic and then quantum dots, are what my lab is recently working on, and we are trying to apply them in different applications, including sensing, especially in biomedical sensing. After the introduction of material, and now I'm going to tell you about what is Raman spectroscopy. And Raman spectroscopy is discovered by C.V. Raman, who is a very famous Indian person, right? And he discovered the Raman effect in 1928. He found that when the radiation is interact with the molecule or object, it will shows scattering effect and mostly relay scattering, but very few percentage, let's say less than 1% of light will show shows the Raman scattering. So Raman scattering is actually a inelastic scattering effect, in which Rayleigh scattering, as I just mentioned, Rayleigh scattering is an elastic scattering, and this kind of inelastic scattering, when we compare the incident radiation energy and the scatter radiation energy, we can find the energy difference. And the energy difference corresponded to the vibrational energy level of the specific vibration of a molecule. Yeah, that's the reason Raman spectroscopy is a molecular spectroscopy, and which provide very similar information with IR spectroscopy, because IR spectroscopy also provide the vibrational energy level of the molecules. But because the selection rule between IR spectroscopy and Raman spectroscopy are different, so the information they provided, actually, they are complementary information. Sometimes when some specific vibration can be observed by IR, but cannot be observed by Raman, and reverse situation may also happen. So usually we will use IR or Raman simultaneously to compare with each other. But for Raman spectroscopy, it shows some more advantage comparing to IR spectroscopy, because when we use Raman spectroscopy, water interference is very limited or will not happen, which water interference is very intense actually in IR spectroscopy. And besides, for the Raman spectroscopy is a non-destructive detection. Yeah, because of these two major advantage, Raman spectroscopy is recently more and more applied in biomedical application. Yeah, that's the reason my lab, we have 3 Raman spectrometers now using different excitation wavelengths, because we are trying to use Raman spectroscopy in different.
老师要讲快一点哦。
Okay, all right. And the next, because the sensitivity for Raman scattering is not very good. Yeah, because of the selection rule and the mechanism. So to increase the sensitivity and the application, we use the surface enhanced Raman scattering, which also called SIRS. Yeah, the SIRS technique is found in 1977. We found when we put the molecule on the nanomaterial, which can exhibit the surface plasma resonance, the Raman signal of the molecule can be enhanced about more than 1 million times. Yeah, so the sensitivity increased significantly. And because of this invention, the Raman scattering application in biomedical is just like a boost. Okay, right. That's the introduction of the nanomaterials and the spectroscopy used in my lab. And next, I will tell you about some application in my lab, especially in biomedical. And first is we try to combine graphene, which is a very fascinating and popular two-dimensional material here. We combine graphene and the gold or silver nanoparticle. We prepare like a sensing chip for SIRS. And after the preparation, we can synthesize very high densities of nanoparticle on the sensing chip, and the size distribution is more even comparing to those without graphene. And after we obtain this series of sensing chip, we use the sensing chip in the detection of nuclear bases. As you can see in this spectra, we detect adenine, cytosine, guanine, thymine, and different nuclear bases, and we can see the good result, especially for adenine. And the second is that's what we are doing recently, because the nitric oxide is a very important molecule in medical sensing, yeah, for the blood stress or for some medical purpose. So we are now trying to detect nitric oxide using SIRS. We modify the what we call 4562 DA-HMP molecule on the sensing chip we have prepared. And when we immerse with the blood with nitric oxide, we can, the nitric oxide in the blood will cause the organic reaction, what we call is triazole formation reaction. And after we compare the spectra before and after detecting nitric oxide, we can see the spectral difference. So we can use it in nitric oxide.
老师，你还有8分钟而已哦。
All right, I understand. Then the next is we also prepare the magnetic doped nanoparticle. For example, we dope iron oxide nanoparticle with silver nanoparticle using the spontaneous oxidation reduction, and we can prepare this kind of nanoparticle. And this nanoparticle, we furtherly use them in as the substrates for immunoassay. And in this application, we modify everything. This is one protein on the surface of the nanoparticle, and we use it in sensing biotin, because as we know, everything and biotin can form a very stable complex, and we use it to show we can do this kind of sensing and like this, okay? And the next, this study is performed by Cynthia, the two lady, okay? And she prepared urchin-like gold nanoparticles like this, like the TEM image shows, and and furtherly use as the substrate for the pathogen sensors. The pathogen we show here is something like E. coli or S. aureus, and this is performed by her. And next, I want to show you the Raman spectroscopy can also apply in the skin cancer diagnosis. And these three spectra are the skin tissue spectra for normal skin, and for the skin with inflammation, and the skin with lymphoma. Yeah, these three different kind of skin tissue. And we perform the Raman spectra collection, and we can found they actually the spectra are different, as can be indicated here. And after we compare these different sets of Raman spectra, we can find the difference, and we can do the like early cancer diagnosis. And the next is the carbon quantum dots for sensing, but this is for sensing iron. So I will skip this slide here. But the carbon quantum dots can be also used in different biomedical applications, such as the contrast agent for the bioimaging. which I did not show you today, but we will do the application in the future. Okay. And the next is iron oxide quantum dots in sensing application. This study is performed by Suderi, who is also our PhD student. She prepared iron oxide quantum dots using ferric chloride as the precursor. And after she prepared, she used the iron oxide quantum dot in sensing cytosine. And because of the fluorescence of the iron oxide quantum dot can be turned on in the presence of cytosine, which is a very interesting phenomenon. And we are still working on it. Okay. And in the past 10 minutes, I have shown you many different biomedical applications in my lab. And I will give you a brief conclusion here. The first is the different nanomaterials are prepared in my lab and characterized well. And the next is as prepared nanomaterial are applied in different biomedical sensing application, including NO, nuclear bases, pathogens, immunoassay, early cancer diagnosis, and so on. And third is other than biomedical sensing. Actually, in my lab, we are also working on the different application of nanomaterial, such as nanocatalysts and bioimaging, environmental sensing, or environmental application, or even the food analysis. This is what my laboratory working recently, okay? And this slide, I would like to thank some of my collaborators, including the professor in Taiwan and some doctors who provide, a doctor who provides us the skin tissue samples. We have also some international collaborators, for example, Professor Hani from Egypt and Professor Asan from Bangladesh and Professor Ganga Raju from India. And the next slide, I will spend some more extra time to show you. If you are interested in my lab, what can you learn in my lab? Yeah, because in my lab, when we do the experiments or research, you have to familiar with many different kind of technique in instruments, including the Raman scattering or Raman spectrometer. You have to know how to use it. You have to perform the experiment by yourself. And meanwhile, UV visible spectrometer, FTIR, these three instruments are the key instrument in my lab. You have to know, or you have to perform the instrument by yourself. And meanwhile, in my department, we also have some core instruments. You also have to know how to use it, because you are the one who should be responsible for your own research, including the DLS, size nanoparticle sizer, and the TEM and the SEM. These electronic microscopy instruments are very important, and the fluorescence. And other than this equipment, you will also know how to use XPS, XRD, lifetime fluorescence, electrochemical workstation, and atomic absorption spectrometry, and BET, something like that. So in my lab or in the department, in my department, you will know how to operate this high-end instrument. And I think it will be one of your profits when you go back to your own country and trying to find a job, because other people may know the instrument, but they don't know how to operate, but you have the experiments, okay? And finally, I want to thank you for your kind attention. And these two QR codes are the QR code for my group and for my department website. And when you have the chance to enter our department website, you please pay attention about several parts, including we have some cooperation with CSRC, which is a very famous Taiwanese company who is extend the factory in India. So they are now recruiting the India student who is studying in Taiwan. They provide a scholarship, extra money for you if you are willing to work in their company when you return to India. They will pay you about $10,000 extra money per month, and totally 4 years. 10,000 Taiwanese dollar means about 30,000 rupee per month. Okay, and if you are interested in our department, you can also try some internship, yeah, to be familiar, to come here and experience the study in Taiwan for 3 or 6 months. And after you finish the internship, then you can make the decision whether you are willing to stay in Taiwan or just you can find some other place, yeah, to proceed your academic career. Okay, right. That's my presentation today, and thank you for your kind attention. Thanks.